Hello, everyone. Welcome to the second lecture on fundamentals of C++ programming. I'm Murtaza, and today we are going to talk about fundamental concepts of C++ programming. As in the first lecture, we talked about compilation language such as C++ and C, and its difference with scripting languages such as Python. We talked about machine code and binary code, and also talked about building blocks of C++ programming. We provided you an example and did the exercise. We also did a Q&A in the last week, and I hope I answered your questions. And still, if you have any issues dealing with programming of the first exercise and the example, you can write comments and ask me directly, and I will try to answer your questions. In the last lecture, we talked about the compilation and the linking. We say we include header files in the source files, and it is a pre-processing process. And then we compile the translation units to object files, and these object files combined with libraries such as the standard library of C++. We make links, and this linker links all the object files to one executable file. Okay, in this lecture, the contents of the lecture are C++ functionalities, one definition rule, compilation time and runtime, automatic compilation and linking with CMake. We also mainly talk about declaration, and in the declaration we talk about identifiers with examples, and also the types, data types, particularly the built-in or fundamental data types. We will do an example and provide an assignment for the next session. What are the functionalities of C++? Why do we learn C++? Actually, it is a very multi-purpose programming language. It can be used for general programming language, procedural programming, object-oriented programming, and generic programming, functional programming. It's a very static and typed compiling language that facilitates low-level programming, and low-level hardware is accessible. What it does also has the capability to interoperate with other languages such as Python. And this interoperability of C++ make it one of the most important and high demand programming languages. One definition rule in C++ is a very important topic. It means that all objects, including variables, functions, templates, they must be defined just once in a translating unit. And modern C++ programming is C programming with zero overhead. Zero overhead in C++ means that it's a principle, means that one does not pay for what is not used. We pay for what we use, and it has to have a purpose. And a person uses just an efficient way as writing by hand. So basically, if it is not efficient as writing by hand or as doing by hand, then it is not useful. And this is one of the most important and basic terminologies in principle in C++ programming. In this part, we are going to talk about compiler and linker errors in C++ programming. In the last session, we talked about compilation and linking. However, when we run the program, we usually face with many errors. And we can divide our errors into main categories. Some errors are related to compilation and some are related to linking the object files. And if we can recognize the type of error, then we basically can easily try to solve the error. The compilation error is due to the failure of compilation due to syntax errors and violating C++ rules. Basically, if we do not write the words or functions correctly, we do some mistakes in spelling, then or miss something, then this is compiler error. And a compiler error includes a line number at which error was detected. As we previously said, that in C++, there is a communication channel between the user and the program, such as Visual Studio, which is an IDM, and the linker errors are errors related to the linking of the object files or with the library, and it is failed, and then files are compiled correctly. However, when they are not linked correctly, we may have a linker error. Examples of linking error are, for example, if we link the object files to one executable file and they do not have a main function, we say that overall computer recognizes that one main function, and if you miss to have a main function, then there might be a linker error, such as could not find definition for a function or variable, undefined reference, such as multi-defined symbols. And problems with finding the definitions for functions, structs, classes, or global variables were declared, but never actually defined in a source file. This also creates linker errors. And also we have another type of issues when we run a program. They are called compiler warning, and it's just a warning for a mistake. The computer recognizes and tells you that, oh, this is the mistake you do and you have done, and if you don't solve it, you may have errors later. And examples are like if you use equal in conditional statements. We will talk about conditional statements and loop statements later. If there we use, for example, equal instead of double equal, then there might be warning. And if we don't consider this warning, then we may have errors later when we run the program. The strategy for solving these errors, both compiler and linker, is to first solve all the compiler errors from top to down, then the warnings, and the last lastly, we have to solve the linking errors. What are the compilation time and runtime? As we know, every action has a process and it takes time. In C++ programming, there are two stages for a program to run. First one is the compilation, and the second is the runtime. And the compilation time, which is called static, of course, is when everything and every variable and functions are declared and defined, and changes are not possible. And in the runtime, which is a dynamic stage, it is associated with the execution time. And the compilation and runtime errors result from these two processes. However, the runtime errors are difficult to identify and fix compared with the compilation errors, which usually pops out in the screen, and you can easily recognize the line and the type of the error, and you can solve it easily. However, in the link error is not easy to figure out and solve it. An integrated development environment, such as Visual Studio, or software where codes can be developed, and they provide syntax coloring, for example, for the type of data. They have blue color. They provide blue color for. They also provide auto compilation, static code analysis, and also a debugger for runtime errors. So basically, they help us to develop the code correctly and easily, quickly. And one example is the Microsoft Visual Studio, and it is used for this course. And I hope you have already installed and used. Next topic is the compilation and linking with CMake. Process of automation is very interesting in many processes. And if we can do it automatically, if we compile and link things automatically, not manually, our time will be saved, and any changes we do bring in the translating units or files, then it's gonna be easier. Because there are several source files and header files in a project, and they have to be compiled and linked. So it takes it needs to be automatic. The aim is to have separate functions in one source code. If one source code changes, only the relevant code needs to be modified and recompiled. For automation, we use build systems such as CMake. In the CMake, which we will also do an exercise later, how we implement this automation. Will be in the next few lectures. It has its own simple scripting language where we can link the files and the libraries. We can also use it for different IDs. So now we're going to talk about declarations. What is declaration? Declaration means that variables, functions, and classes are mentioned in a header file where we are going to use it. In the declaration, we define the type of the data in the function. We also use signature for example, function or variable, and it means it basically has two parts: type of the data or variables and the identifiers. The type defines the type of values the variable holds, and the identifier is a name given to variable for reference and access data. A variable declared can also be initialized. For example, if we have double weight, the double is a data type and weight is identifier, and it is uninitialized. However, if we say double weight equals to 2.4, then it is also declared and initialized. Initialized means we just put a value for a variable, and then in the main function we can use them. What is the declaration identifier? As we previously said, identifier of variable in C++ can be upper and lower English case, lowercase English language letters, underscores, and digits from 0 to 9. And identifiers should not have the number at the beginning. For example, we can't say 9x as a variable. And there should not be a white space between the words and the letters. In C++, it is a very case sensitive and therefore needs more attention. Means that we should not use capital A instead of and lowercase letter a. And longer names for variables are favorable since they provide a meaningful explanation for the purpose of the variable or the function. Usually, variable starts with a lowercase letter, and if there are multi-words, they can be connected with underscore or camel case. That means that, for example, if we have a space mean speed, we can write it in two forms, such as space with lowercase letters, underscore, mean, also lowercase letters, underscore, speed. With camel case, we can say space as using lowercase letter, and then mean as big or capital letter, and speed with capital A's, and together this is one variable. Okay, there are some examples for declaration identifier. It's very important because if we do not consider these principles and rules, we may have too much syntax errors later. And if we consider examples, for example, one is speed, we have true and false column. This is wrong because we can't use digit and the first letter or the first character of a variable. If we consider area size, it's also false because first letter is uppercase and it is separated with minus, what do you say, and not with the underscore. And the room height, for example, if you want to consider, it is a wrong declaration because there is a white space used. Room is one word and height is another word. Basically, they have to be connected either with underscores or with can be joined with one as one word or combined. And the width inside quotation is also false because it's using strings. It's not allowed for declaration. Volume exclamation mark is also wrong because we can't use punctuation marks such as question marks or exclamation marks, and they are not allowable for declarations. K2, it's correct and true because digits is used after later. And book number is also wrong because we use O and that special character. This is not an English character, therefore it's not correct. However, maximum speed, it is true because this is capital and they are combined together and they're connected correctly. Now we're going to talk about building our fundamental data types in C++. We have around 9 building types, data types. For example, double is used for decimal numbers or real numbers, both minus in positive, negative and positive real numbers. And it holds 8 bytes of space in the memory. Integer or int, it's used for holding positive and negative integers. We use char for declaring from A to E scores. We can use char. And unsigned integer, it just stores positive integers such as 3, 75. It cannot hold negative integers. And short is 10 or 12, consumes less memory and holds small numbers. If we want to declare short numbers, we would better use short instead of integer because it holds less memory. For storing large numbers, we usually use long, and it consumes large memory. However, for real numbers of less accurate, we use float. For example, if you want to initialize the pi number with 3.14, as you know, it has a very long decimals. We usually use float. For one false or on and off variables, we usually use bool. And constant is also used for storing constant values that cannot be changed later. For example, constant integer pi. Pi is because it has a very constant value, and we usually use const. Okay, I hope you understood all the concepts. And still, it's a bit complicated. If you have any questions, please ask me or write me in the comments. I will try to answer your questions as soon as possible. We now go to the example, which basically is about calculating the speed of a vehicle. In this example, we have an initial speed for a vehicle, for example, a value of 10 meters per second. And then we calculate the next speed according to the acceleration it takes, it gets, and the time difference. We do have a formula for that, which basically says speed equals to the initial speed plus acceleration times the time difference. So of course, again, like previous example, we go to now we go to the Visual Studio. Um, here is the project example 2. We have header files of speed.hpp and source file of speed.cpp, as you see here. And the header file, we declare our variables. Basically, we say that the variables is going to be double type, and we have speed, we have acceleration, we have the initial speed of the vehicle, we have time 0 and time 1, for example, and we conclude our statements here. Basically, all variables here have the type double, and they may have the real number of values. We can also have here long double, which basically means it can have a very huge number. It can hold huge number. Here we consider type double. In the C++ file, we have all the inputs and outputs, and basically we are gonna include, because it's a bit mathematic, we may include the IO stream or the standard library. We also need to include the header file, and to include the header file, we get the quotation and the speed.hpp. We have one main function for this project, and basically in the main function we may have inputs and outputs. We use comments to make it clear that this is going to be inputs, and here we use the standard library functions std.cout, and this will be shown in the screen. So we also may conclude our statement with \n. And here we also repeat this function again. And the first input would be to enter the initial speed. And the initial speed would be basically what we have declared in the header file, and initial speed. We also have another variables, so basically the acceleration of the vehicle. For example, to enter the acceleration, we basically have the C dot in, and in the C std.cin we have acceleration. We also have other variables, like we have the time 0, and that is going to be time 0, excuse me, is Cin, and we have time 0. We have std cout, and it's going to be time 1 here in this example, and we may have to end the line, and this is basically time 1. So these were the inputs that the user has to make clear. And we also have the outputs for this example. And the outputs would be to basically we need to define the speed. And the speed is equal to the initial speed plus the acceleration times the time difference. Well, delta time is basically time 1 minus time 0. And this is the formula for the speed. And so the speed equals to the speed that's all for this example. What we all have, because it seems that it runs. We run the code, and a new screen pops out as you already expect. And here we have the result of this algorithm. And here we see that there is written enter the inputs. First, enter the initial speed. For example, we say that the initial speed of the vehicle is 8 meters per second or 8 to 25 per second. And the acceleration rate for the vehicle is, for example, 3.5 meter per second squared. And the reference time that we consider is 0. And the next time step we consider the speed is around maybe 7 seconds later or 7.8 seconds later. As you see here, we have the speed equals to 35.55 meter per second. You can run the code multiple times. Result may be again and again. To make the code a bit clear, we need to work a bit on components. We say, well, the inputs are, we say that the units are meter per second squared, and seconds. The speed, here we also can write that the speed would be in meter per second. Or here we also can add meter per second squared. Yes, the time zero is first and second. Um, and this is also true for the second time, and we can write the acceleration as meter per second squared. And the speed is in meter per second. We can see this green, and again, as you see, the color is now getting better. Say enter the initial speed in meter per second. We say, well, speed is 6.6 meter per second. The acceleration of the vehicle is 2.4, and time zero is 2 seconds, and the next time step is well 6.3 seconds. And you here see that the speed is equal to 16.92 meter per second squared. And the code here and the executable file here is example2.exe. I hope you understand the compilation, the linking. You understand how to declare variables. You understand the types of data, basic or built-in types. You understand the declaration signature use. How we declare different types of names. How we use the standard library, and how we start writing the code. I hope you do the exercise, and if you have any questions, you can write in the comments, or you can also participate in our Q&A session. Don't forget to write your WhatsApp number to me directly, and I will try to add you in a WhatsApp group so that we can have communication and better understanding of the topics. Right, that's all for today. Wish you happy Christmas, happy holidays, and best of luck with your studies and holidays. See you.